Hello, how are all of you? Well, this is the first lesson of our second week of the summer course. It's moving right along, or in this case, second week, but it would be like a third week on a regular one. So yeah, there's a world of difference between the two courses. First of all, this is the first lesson that uses the textbook. So I want you to see what your textbook looks like. That's what your textbook is. So if you don't have a copy of it, you do need a copy of it, or some way to get a copy of the assignment pages for this particular lesson. We're going to start looking at application problems. Now, when we think about application problems, many of you go, word problems. Oh my, how horrible. Because you don't enjoy word problems, you get frustrated with them, and it's because you don't know how to tackle them, and you don't realize how important word problems are. Word problems is actually math applied to life. When you run into mathematics in life, most of the time it's not going to be presented to you as 6 plus 8 or 6 times 585. It's going to be presented to you with words. And you're going to have to learn how to understand those words, translate those words into action. And when you translate it into a number sentence, now you're translating it into action form. So it takes a lot sometimes to get into these. It's a very important life skill for a number of reasons. It's important for mathematics to be able to do math in life. In our lives today, I don't think there's anything that we can do that completely avoids having to use mathematics in some way, shape, or form. So you need to learn how to do that. Also, mathematical thinking, reasoning, develops skills that help you solve problems in life, just everyday problems in life. And it's very important. It's a very important tool in your decision-making toolbox, is to be able to think logically, to be able to think in ways that help you solve the problems that life throws at you. Okay, so if we're going to think mathematically, what are some of the things that we need to be able to do? Well, first of all, you have to try to understand the problem or situation. If you don't understand it, it's awful hard to start solving it. Next, we need to identify important elements. What is it that we're trying to do with this problem? What's the information given that enables us to be able to do that? What kinds of interaction takes place between the elements? Are these interactions looking at dividing? Are they looking at becoming less? What is happening in this interaction between the elements? Another way to solve problems is look for consistent patterns. Okay. What is the question asked that needs the answer? So the question, what is it? You can find an answer, but if it doesn't answer the question the problem wants you to solve, you haven't finished the work yet. And then last of all, one of the things you need to ask yourself is the answer logical? So these are just basic problem-solving skills. You can apply these kinds of problem-solving skills to almost anything out there, almost any kind of a problem you'll run into in life. Okay? A form of thinking is called reasoning. And what is reasoning? Reasoning is the drawing of inferences your conclusions through the use of statements offered as explanation or justification. That is reasoning. In this course, we are going to look at two different kinds of reasoning. The first reasoning we're going to look at is inductive reasoning. So what is inductive reasoning? It is a line of reasoning based on observation of specific examples. Observation of specific examples. Those are key words in that definition. So, another way to say it is inductive reasoning is a generalization from observing examples. Okay. So here's one from science. People are mammals, dogs are mammals, cats are mammals. Lots of mammals are out there. Cows are mammals, many, many different animals are mammals, okay? And if we dissected those, we would find out that every one of them that we looked at had lungs. So we have lungs, dogs have lungs, cats have lungs, so do cows, so do horses. So we look at all those animals and we say, those animals have lungs. They also fall in the category of mammals. Therefore, we could then, from that observation, we could make the generalization, all mammals have lungs, okay? So that would be a way that we have used an observation and turned it into a generalization, and therefore we have used inductive reasoning. Here's another one. In New York, in the month of January in 2010, it snowed 30 inches. In 2011, in the same city, or the same place, it snowed 35 inches. So according to those 2 years, we have observed that in the month of January, it snows 30 inches or more. So we could make a generalization and say that in New York, in January, it will always snow at least 30 inches, okay? So that is taking and making a generalization from an observation. So how do we use this in math? Well, here's an example. as you look at that example, we have 1, 4, 9, 16, and 25. This is a sequence of numbers. In other words, it's numbers listed one after the other. The first one is your first term, second term, third term, fourth term, and so on. Okay? So here is a list of 5 numbers. What would be our next number? Well, to do that, we have to decide what is happening in this list of numbers in order to apply that to finding the next number. So, what is it going to be? The next 3 numbers in this sequence. And that's what your first few problems are going to ask you to do. So first of all, we have to figure out what is happening with these numbers they already gave. Well, there's actually 2 different patterns that we can observe on this. Remember, looking for patterns is one of the ways to do this. This is our first number, it's 1 squared. The second number is 2 squared. The third number is 3 squared. The fourth number is 4 squared. The fifth number is 5 squared. So what are the next 3 numbers? Yes, you're right. It would be 6 squared, or 36, 7 squared, or 49, and 8 squared is equal to 64. Okay? That would be our list of numbers. And the rule would be x squared, x meaning the number of the term. So we could call this the rule, or the generalization that comes from this is any number, I'm going to put a sub n is equal to n squared. N refers to the number of the term. So that is one pattern that we can use to decide what that is. If we were asked to find the 15th term of the pattern, it's not hard to do, because then we put 15 in for n, and that becomes 15 squared, which is equal to 225. Okay? That's one way to look at that pattern. There is actually another way to look at that pattern. I'm going to put it over here. Another way to look at this pattern is to look at what's happening between the numbers. Okay, 4 minus 1 is 3. So therefore, I add 3 to 1 and I get 4. I can add 5 to 4 and get 9. I can add 7 to 9 and get 16, and I can add 9 to 16, and I end up with 25. So what are these numbers? These are odd numbers. So I can keep going and do the same thing. 11, 25 plus 11 is 36. 36 plus 13 is 49. And 49 plus 15 is 64. Okay? But now to find out what the 15th term is of this sequence is not quite as easy as the other one. It requires us to think about what's happening here. If I look at 3, and I'm going to be from first to second term. So if I'm looking at my second term, my n is equal to 2. Well, 2 plus 1 would be 3, but then 3 plus 1 wouldn't be 5. So that doesn't work very well. So we have to figure out a way that expresses the increase in these odd numbers. So we would say that 3, we could say, is 2 times n plus 1. We would try plus first. 2 times 2, because we're looking at the second term, 2 times 2 plus 1 would be 5. That's going to be too big. We want it to be 3, so if we subtract 1, we would have it. times 2 is 4, minus 1 is 3. 2 times 3 is 6, minus 1 is 5. So this is what's going to give us. So it is the a sub nth term would be a sub n minus 1. It would be the 14th term, whatever that is, plus 2 times 14, because it's the 14th, no, 2 times 15 for the 15th term, minus 1. So it would be the 14th term plus 29. And so we'd have to add them and figure them out. So this is a harder way to do it, but it also works. It's another pattern or generalization we can use. Okay? So the first one, n squared, is actually the easier generalization to use. All of these that we've done so far are inductive reasoning patterns. And the reason they're inductive is because we observe a pattern and then we apply that pattern to the rest of it. So let's look at some other sequences. There's another one. 4, 9, 14, 19. What would be the next 3 numbers in this sequence? Okay. As you look at that one, what do you have? Well, 9 minus 4 is 5. 14 minus 9 is 5. 19 minus 14 is 5. So what does that tell us? It tells us that the pattern is you add 5 to the previous number. So 19 plus 5 would be 24. 24 plus 5 is 29. 29 plus 5 is 34. And so on. Okay? So what happened? Our rule was add 5 to previous term. Okay, let's look at another one. 2, 6, 18, 54. Okay. What are the next 3? Well, let's look. What's happening here? Well, obviously we're not adding the same thing. So the next thing we can try is maybe it's a multiplication. Well, 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. So 54 times 3 would be 12, carried by 1, 15, 16. We'll let you figure the rest of them. So our rule is what? You're going to multiply 5 times the previous term. So we have 2 different patterns, but they're all patterns that we can predict. How about this one? 5, 6, 8, 11. Okay, so what's happening here? Well, we added 1 here, we added 2 here, we added 3 here. So for this one, 11 plus 4 is 15. 15 plus 5 is going to be 19. No, 20. Sorry, wrong number. 20. And 20 plus 6 will be 26. So this one, you're adding consecutive integers. the best way to describe it. Okay, so all of these again are inductive reasoning because we have actually looked to see what's happening with them. All these inductive reasoning sequences that we have dealt with fall into one of three categories. Your first category is an arithmetic sequence. And an arithmetic sequence adds the same number each time. It could also be a subtraction. I'm going to write or subtracts. The same number each time. Okay? The next one is a geometric sequence. And your geometric sequence multiplies by the same number each time. And your third category is neither. And neither means it is not arithmetic or geometric. It is something different. Some of the neither ones have specific names, but we're not going into that right now, okay? So we have three kinds of sequences. Now, if we look at this first sequence we just did right here, is this one arithmetic, geometric, metric, or neither? Well, we added 5 each time. Therefore, this sequence is arithmetic. Okay. Number 2 here. We multiplied by the same number each time. Therefore, this sequence is geometric. And this one, we didn't add the same number, neither did we multiply by the same number. Therefore, this particular sequence is neither. Okay. Now this explains the first part of your assignment. In actuality, much of it will ask you to do that. Okay, so let's look now at our next idea, deductive reasoning. Deductive reasoning. So what is deductive reasoning? Deductive reasoning is a process that begins with commonly accepted facts. And logically arrives at a a specific conclusion. Okay. Now, I'm going to stop with there and start another video because we're going to run out of time on this one.